Dear student, Assalamu alaikum. I hope all of you doing well. In our advanced mathematical economic course, today we are going to explore the first order difference equations. Let's quickly explore our today's outlines. Outlines includes the difference equations, types of difference equations, first order linear difference equation, solution of the first order linear difference equation, time path, particular function, complementary function, general solution and definite solution if a does not is equal to 1. General solution and definite solution if a is equal to -1, and at the end of the lecture, comprehensive summary of the lecture. Let's start. First of all, we define the difference equations. A difference equation is a mathematical equation that describes the relationship between values of a sequence or time series where values at one point in sequence is related to the values at previous points through the differences rather than the derivatives. It is a very important point. In differential equation, we deals with the derivatives, but in the difference equations, we deal with the differences of the current series and lag values or lead values. Here we explore the different types of the difference equations. There are the various types of the difference equations, but in this course, we are limited only the first order difference equations, higher order difference equation and their solution, and the qualitative part of the nonlinear difference equations. Now briefly explore the first order difference equations. The standard form of a first order linear difference equation can be written as yt plus 1 plus ayt is equal to c, where yt plus 1 is the value of the sequence at time t plus 1, yt is the value of the sequence at time t, a is the coefficient multiplying by the value yt, and c is the constant term added to the equation in the right hand side. Now explore the two different types of the first order linear difference equation. Number one is the non-homogeneous case where c is equal to 0. The standard form of the non-homogeneous case is the same as the standard form of the difference equation. This is yt plus 1 plus ayt is equal to c, where right hand side is non-zero or c does not is equal to 0. Homogeneous case, yt plus 1 plus ayt is equal to 0. Look at the difference. Here right hand side is 0. That is c is equal to 0. If the right hand side is 0, this is called the homogeneous difference equations. Time path. The time path is similar to what we have previously studied in the differential equations, depending on the complementary function and particular function. The equation for the time path is the given below. It is the sum of the complementary function and particular integral. So yt is equal to yc plus yp. Our objective in the difference equation is also to find the time path. Note that the differential equations depend on the derivatives of the dependent and the independent variables, whereas the difference equations depends on the differences between current values and lead values or lag values of the series. Here we explain the discrete time path and difference equations. Look at the equation number 5. Delta yt is equal to yt plus 1 minus yt. This equation tells us that delta y, change in yt, depends on the difference between the lead value, that is yt plus 1, and the current value, that is yt. So the main objective of the difference equation is to find out the particular integral and the complementary function. So first of all, we derivate the particular integral. The derivation of the particular function, that is yp. Let's assume the non-homogeneous equation number 2, yt plus t plus yt plus 1 plus ayt is equal to c. Assume that yt plus 1 is equal to yp and yt is also a yp. We are essentially assuming that the sequence remains constant over time. In other words, yp represents the steady state or equilibrium value of the sequence. So if yt plus 1 is equal to yt is equal to yp, ठीक है? Look at this equation, the value, put the value of the yp into the equation number 2, that is yt plus 1 plus ayt is equal to c. We get yp plus ayp is equal to c. This is the equation number c. Look at yp is the constant in two terms. So by taking the yp common, yp into 1 plus a is equal to c. So here is the remaining part. Because we want to find the value of yp, and that's why we divide 1 plus a both sides of the equations. So if we divide 1 plus a both sides of the equation, remaining we will get the value of the yp, that is the particular integral. So yp is equal to c over 1 plus a. Here we derive the yp. So yp is the constant value because c is the constant and a is the constant. So yp is the constant value or the equilibrium value. It is also called the intertemporal equilibrium. Our next target is to find the yc, that is the complementary function, derivation of the complementary function. For derivation of the yc, we consider the homogeneous case from equation number 3. Equation number 3 is yt plus 1 plus ayt is equal to 0. From our previous knowledge from the differential equation, here we assume the current value, that is yt is equal to a b to the power t. So in the similar fashion, if yt is equal to a b to the power t, so yt plus 1 is equal to a b to the power t plus 1. Here we assume two values. So substitute both values. Yt is equal to a b to the power t and yt plus 1 is equal to a b to the power t plus 1 into the equation number 3. We will get a b to the power t plus 1 plus a arbitrary constant capital A b to the power t is equal to 0. Here b to the power t plus 1 decomposed into the two component, a b to the power t into a b to the power 1 plus a b to the power t is the same. By taking common a b to the power t, we will get a b to the power t into b plus a is equal to 0. Or if we find the value of b, so b is equal to minus a. The value of b put in the equation number 9, that is yt is equal to a b to the power t we assumed previously. Putting the value of b, we will get yc. So yc is equal to arbitrary constant capital A into minus a to the power t. This is the value of the complementary function. So our next objective is to find the complete solution, that is the obtaining the general solution. We know that the general solution yt is equal to the sum of two important components, that is yc plus yp from equation number 4. Substitute the value of the complementary function and particular function to get the general solution. Here is the general solution is equal to yt is equal to arbitrary constant capital A into minus a to the power t plus c over 1 plus a. Our next target is to find the definite solution. For definite solution, definitely we assume substitute t is equal to 0 in general solution to get the definite solution. So general solution is the yt is equal to arbitrary constant. The blue part is the yc complementary function, and the red part is called the particular solution or function. So yt is equal to arbitrary constant capital A into minus a to the power t plus c over 1 plus a. So if we put the value initial condition t is equal to 0, so here is y naught is equal to a into minus a to the power 0 plus c over a, or y naught is equal to a into 1 plus c over 1 plus a. As we know that because minus a to the power 0 is equal to 1, we substitute the value of minus a to the power 0. Solving for a, here a is equal to y naught minus c over a, we obtain by subtracting both sides minus c over 1 plus a. So substitute the value of arbitrary constant in the general solution, equation number 11. We will get yt. Here first we check the what is the equation number 11. Yt is equal to a into minus a to the power t plus c over a. Equation number 11. Substitute the value of a, which is available in the equation number 12. We will get yt is equal to y naught minus c over 1 plus a into minus a to the power t plus c over 1 plus a. The equation number 13 is called the definite solution. Why we called the definite solution? Because there is no arbitrary constant. It is free from the arbitrary constants. What is the difference between the definite solution and general solution? In the general solution, the arbitrary constant a is available, but in the definite solution, there is no a. We eliminate the value of a by substituting the value of a. So general solution in case of a is equal to 0. In case of a is equal to 0, yt is equal to a plus ct. And the definite solution in case of a is equal to minus 1. Solving for a by assuming t is equal to 0. By substituting t is equal to 0 in 14, we will get yt is equal to a plus ct, or y naught is equal to a plus c into 0. So y naught is equal to a. Substituting the general solution, a is equal to y naught, we will get, by substituting a is equal to y naught in 14, we will get yt is equal to y naught plus ct. Now a quick summary of the lecture. Standard form of the first order difference equation: yt plus 1 plus ayt is equal to c. Non-homogeneous case, if a is equal to 0, yt plus 1 plus ayt is equal to c. Homogeneous case, if c is equal to 0, yt plus 1 plus ayt is equal to 0. Here the right hand side is equal to. The objective of the difference equation is to find the time path. The time path is equal to yt is equal to yc plus yp, that is the sum of the complementary function and the particular function. The particular solution or the equilibrium solution yp. So yp is equal to c over 1 plus a complementary function. Yc is equal to capital A, that is the arbitrary constant, into minus a to the power t. By adding both, we will get the general solution yt is equal to a into minus a to the power t plus c over 1 plus a. Definite solution where a does not is equal to 0. A is equal to y naught minus c over 1 plus a. If t is equal to 0, here is the value of a, and yt is equal to y naught minus c over 1 plus a into minus a to the power t plus c over 1 plus. General solution, if a is equal to 0, yt is equal to 1 plus ct, and definite solution, if a is equal to 0, value of a is equal to y naught and yt is equal to y naught plus ct. Thank you for watching. If you have any queries, please feel free to email or comment on the video. In the next video, we will solve the numerical value example of the difference equation from the book of Alpha C. Chiang for further clarification and comprehensive understanding of the difference equation. Thank you.